All right, good morning, everybody, to this Tuesday. Yeah, I'm pretty sure it's Tuesday, where we are continuing our discussion on derivative and derivative properties that allow us to get around that messy and unlikable limit definition. It is the way it is. The limit definition is how the derivative works, but I don't want to do it unless a question specifically asks me to. In order to get around it, I have to use some established derivative properties. And those properties are established through looking at the limit definition. Someone has to do it, but that someone doesn't always have to be me. Before we get started, can someone just confirm in the chat that they can both see and hear me? And we're good to go. Anyone at all? Now, I don't mind speaking to myself. I mean, it's fun. I do it all the time. But I'm kind of here for you. All right. So let us review our derivative properties that derivative. No, that's not right. Maybe I should learn how to spell. Derivative. There we go. Properties. It's something that people they just glance over and they don't give it enough attention. Build that base, that foundation. The rest of the course depends on it. They're not taking the time to be careful and very aware of what properties they are allowed to use and when it's appropriate, when it's not appropriate. They just sort of, it'll all work out, whatever, I'll just do some stuff and find the derivative. And then when things get complicated, they don't really know what they're doing, and that's when it all falls apart. The effort you put in now will pay off in the end. And the end of the course, that last month, can be super easy because it's all built on the things we are establishing now. Now, in no particular order here, I have my main rule, I guess, property. It's not a rule that's made up, though it is called the power rule. It is a property that I can prove in general from the limit definition. It's just a little bit difficult to do in general. So we looked at some specific examples, easy versions of powers of x, though this power of x can be absolutely any real number. The power rule then says the derivative is the original power of x, that number in front as the coefficient, and the new power of x is 1 less. So any n that is not 0. So that I actually have a function that involves and depends on x. But the power rule only says what it says. And my functions could have numbers around this x to the power of something. It could be in combination with other powers of x or other stuff. So we need what I'll call the constant times a function property. I wish it had a nicer name, but no one really cared enough to name it. It's very sad. Sad property. It's very important because without it, I can't isolate the power of x to then use the power rule. It says that if I have a function, but that function is some number times the x portions, the essence of the function, there's a number that it gets multiplied by, then it's as simple as I would like it to be, that the number can be kept in front or pulled out in front And then I just need to look at the derivative of what I call the essence of the function. The x portion is where the function is really made. But I need it. I need this property. It should have a name. I wish it did. Then I also have the sum or difference property. Really, this is two properties in one for the plus, one for the minus, but because they look the same, people just merge them together. Technically, it's two properties, saying that if I have, let's say here, an f plus or minus a g, so my whole function is made up of different terms added or subtracted together. Then I can look at, oof, that's a wobbly D. I can look at each term separately and then add, what? Why is everything so wobbly? I know why. It's D to L again, causing some lag. I can look at the terms separately and then add them up or subtract them, whichever one was done originally. I can put them together in the same way. Now, those are very simple properties to the point where you might think that, of course, it works like this. Why wouldn't it? It's as simple as I could hope it to be. But there are other situations where the property isn't quite as simple. We can't do them yet, but we'll build up to it, where the property isn't what I want it to be. It's just not as simple, and it's just the way it is. Right now, these properties, luckily, are fairly straightforward and easy to remember. They are as simple as I would hope them to be. But they still have to be established by way of the limit definition. Someone had to go and look at this. What does the limit definition do to this kind of function? Oh, okay, it turns out to be this. Now we can sidestep the limit definition. You can't do that until someone does it. We're not obsessed with proofs. We've done this one, the constant times a function property, just to give you an idea what it's about, but you don't have to do it. And then lastly, we could have just a constant. So we need to have a property that tells us. If you wanna get around the limit definition, there has to be a property that you can call on. The constant property is also in our list, saying what we can do with the constant function. Just y equals some number. That was horizontal. Horizontal line has slope 0. So that wasn't hard to motivate. But if I can't call upon a property to justify how I get the derivative, I have to use the limit definition. So it's one or the other. You use the limit definition if the question specifically asks you to. Otherwise, I want to get around it because it's a lot of work. It's messy. But I have to have a property for every single thing I do if I am going that route. And that's where people get confused. They just like they see patterns where there aren't any, or they just get used to it. Or they think they're getting used to it so quickly, and they don't take the time to be aware of what they're using when. And it's not going to stay this simple. When it gets more complicated, I need a solid base that I can build on. Sorry, I made the wrong kind of page here. This one. Need a solid base. It doesn't seem like it's necessary until things fall apart. I've seen it many, many times, unfortunately, and I don't want that to happen to you. And the reason it falls apart is because people did not put in the time and paid attention now when it's still simple. Now, we did, I think it was number 3 in these problems, I think. Let's just do number 1. All we're doing today is practicing this. That is literally all we're doing. Our schedule is nice and slow now because it's very important. So, oopsie, we'll do a problem. It'll be from 5.2, and we will call it number 1. Why not? Number 1. Now, what is number 1? I am just going to move my questions to my other screen so that I can just see it, and you can just trust me that this is the function. Stupid line. Get away from me, line. Alrighty. Function is 3x squared plus 3x plus 1. Now I'm going to move it over here so I have maximum space to write my step and say which properties I'm going to use. So I know in general, eventually, we won't have to say which property we're using every time. That's when we get used to everything and it's easier. In the beginning and today, I want to emphasize and say which property I'm using at every line. Everything I'm doing has to be justified by a property. All right, so question for you. What is the first property that must be used when I'm trying to find this derivative? I am very happy that you said power rule because we are so tempted to focus on the power rule that I absolutely agree. I want to use the power rule all the time because I see powers of x. Absolutely. But the question was, which one is first? Because the power rule says only what it says. It says nothing more than this. It says that if you're trying to find the derivative of x to the power of something, see, there's nothing else in these square brackets, then the power rule can handle it. If there's something else in the square brackets, the power rule is not ready. It might seem like a technicality, but it might seem a little silly right now because we only have 4 properties. And let's face it, the bottom 3 are not super hard. That's not going to stay like that. I want to lay that base. But obviously, you said power rule just to test everyone. That was obvious to me because that's how many people think. And I totally understand why. The power rule is so powerful. It's way more important than any other property. But technically, it's not. If I can't get to x to the power of n and isolate it, the power rule is not ready. It's not ready. So I need to use the sum property first, allowing me to systematically isolate and work my way towards being power rule ready. I can only emphasize the importance of these things, but there's always going to be someone out there thinking I am being silly. Believe me, I'm not. I'm trying to avoid mistakes that I see every single semester, and they're all related to not being aware of what the properties are and what I'm allowed to do and when. Okay, so now let's focus on these first 2. Not side arrow, what am I doing? Let's focus on these first 2 because the third one is different, right? Okay, I could have done the third one next, but I'm just focusing on the first 2. For those first 2 terms, what is the next property? And only by you attempting an answer, saying something, that's your test to see where you're at. And if you say the wrong thing, so what? Then at least we know and we can build on it. But if we never try, then we might kid ourselves and think we're ready to move on when we're actually not. We have to make those checks. Constant times a function because I know x squared is ready. It's almost there. It has a number in front of it. The constant property will come later. I just want to do one at a time to not confuse anyone. But yes, you could do them in the same line, absolutely. For now, it's our first example for the day, so I won't. So now the constant times a function property, that I'll shorten like this, allows me to rewrite the derivative and isolate the power of x. They I don't give them much attention because they seem to be saying exactly what I think they should say. It hardly even seems like a property. But there are other things that don't work in the way that I think is obvious. It's only because we have very limited experience. This list is very short. Okay, so now we might want to, maybe want to update this guy and leave the rest, leave the best for last. I just, for this first example, want to do one at a time. So, constant function, 0. Whether you write the 0 or not, I don't care. Constant property. I remember in high school, we did our homework, and sometimes like this, not derivatives, but something else, something cancels and you get a 0, right? And so I wrote the 0 to show that things canceled and now they're gone. They're not actually gone, they're just 0. And my teacher saw my homework and he just snapped. No, you can't show a 0. What are you doing? Why? Why not? 0 is important. Let it have its moment in the sun. Why not? I didn't see why he freaked out. It's 0. Write it. Don't write it. I don't care. He's not happy. So now, yes, you could have merged those lines, and we'll do it in the next one, perhaps. Now we're ready for this x squared. It's isolated. It is the only thing in the square brackets. We are ready to use the power rule. Yay, power rule. I wanted to use you from the start, but technically I wasn't ready. We'll get used to these things very quickly and merge them all in one go without even worrying about it. But that's risky. As soon as I stop thinking, things can catch me. Okay. What about the middle one? Is that also the power rule? Derivative of x? Is it the power rule that I'm using? Question to you. Well, you can't answer my question with a question. You have to commit. Well, I only have these. I won't give you something that I can't handle, right? And I only have these 4 properties. I'm not going to jump outside of these 4. So if I have the derivative of x, which I do, I'm going to have to handle it with one of these properties. It's not a constant, so that's out. It's definitely not a sum difference. And there's no number in front of the x. So the only thing left is the power rule. Because x is just x to the 1. It's a power of x. Don't discriminate against 1. It's not very nice. It's a power of x. We just happen to not write the 1 because something to the power of 1 is so common that we made the agreement. When it's a 1, we don't show it. But everyone should still see the 1 there. Power rule. Absolutely. Power rule. The 3 is there. Let's just see what the power rule does. 1 goes in front. The new power of x is 1 less. And I'm not going to write the 0. So what happens here? That's x to the 0. X to the 0. Anything to the 0 is? Yes, today is going to be full of questions because that's how we check. Anything to the 0 is 1, but I like that you're answering every question. That is how we're going to get better. Doesn't matter if it's wrong. We don't know what to do and what to review if we don't make an attempt. I don't care if it's right or not. I care about trying. That is how we get better. Anything to the power of 0 is 1. And if you need to review these things, oh goodness, that's, I don't even know what grade that is. Let's say 10. I don't know. Doesn't matter because x is a number, right? Somewhere. X can be a number if I want it to be. Anything to the power of 0 is 1. We have to remember that. So, the power rule still works. Now, admittedly, I will be the first to admit that this includes the derivative of x, which we've now figured out is 1. But I can't help myself. and see this as another property. I can't help myself. That's how I remember it because it looks different. It does. I don't see the power. It is as an answer that doesn't have an X in it. It looks weird. It does technically fit in the power rule. It is the power rule that I'm using. But when I try and remember that the derivative of x is 1, it's useful to remember as a separate property. Let me make that very clear. The way I structure things in my head to help me remember, I have the derivative of x kind of as a separate special property. But it's not. It is a part of the power rule. Okay? Then I can simplify this if I want to. I don't have a huge emphasis on simplification, but there it is. It's nice. If it's easy enough to do the simplification, why not? Why not? If it's a lot of work, double check if the question even wants it. Okay. So if this takes a while, it's okay. That's why I spend the whole day on this. And we're gonna have more practice in a way tomorrow and the next day because it is super important that when I get to fancier and fancier properties that look stranger and stranger, then I have a solid base that I can build on. And I can focus on this new weird property. Right now, nothing is super weird, I hope. That these bottom three are pretty much what I want them to be. If there's a number in front, I just want to leave the number in front. If I have multiple terms, I just want to put them together in the same way. It's as straightforward as I could want. Power rule, perhaps not, but we saw a pattern. It's okay, we can handle it. And a constant becoming 0. That's also, 0 is also as simple as I can want. Where did that line come from? Get out of here, line. Any thoughts on that? Yeah, we'll just do more. When in doubt, more practice. It's what we're gonna do. It's the only thing that's gonna work. Why not do it? And with each one that we do, we get a little bit better, a little bit better. But you have to get, honestly, I don't have a lot of problems in 5.2. Definitely check the other resources if you need more practice. Uh, the I have to get to a point where it is so straightforward. You are annoyed at having to do another question. That I have to eventually look at a problem like this and be so comfortable with everything I'm doing, every single step, that you go, of course it's the sum property. Stop annoying me with these questions. It's obvious. I've done enough of these. Of course it's the constant times a function property. I know it's a constant property. I know when the power rule can be used. It has to almost be annoying that you've done so much of these. Now that amount that you have to do is different from person to person. I don't know. It's up to you. For some, it can be 5 questions and we're done. For some, they need 20 questions. Whatever that number is for you, that gets you annoyed because things are so easy now, get to that point and you will laugh at certain points in the rest of the course. You will laugh because it's so easy. But don't do it, and it's a tough time. I'm not gonna lie. It's gonna be tough. If your base isn't solid, somewhere it's gonna show, and that's not a good time. And I'm trying to help you and avoid that because I see it so much. Check a question here. If we do it this way, we don't have to find the limit or anything. No, the whole point is I don't want to touch that limit unless a question specifically says, like, I'm a little zoomed in here, but I'll try and find it. Unless, oh, let me zoom out. This is way too much. Here, unless the question specifically says use the limit definition to determine the derivative. I will not do the limit because it is tedious, time consuming, difficult, messy, all of the bad stuff. But fair enough, there might be a question that says use the limit definition. But then also see the functions are quite simple because we understand the limit definition is messy. But in that case, you have to do it. If it doesn't say, definitely never ever do it. You will waste time for one and probably make a mistake because using the limit is so much more tricky. We stop when we have our answer. Yeah, where's it now? Answer. Yeah. You can even stop at this line. Okay. Unless the question says simplify your answer, which I try and avoid because you've done that already. High school is full of simplification. You don't even have to simplify it. But we'll see that there are points where it's necessary. And we don't need the difference quotient. No, that's part of the limit definition. Excuse me. Clear my throat here. I almost choked up when you said different quotient. Like, what is that? Ah, it's a scary word. The whole point here is to get around the low level. Think of this as levels. That at the bottom level, I have the limit definition. But at that level, things are messy and technical and blah, and it takes long. Nothing is fun there in comparison. I want to level up to where I can find the same answers without digging in the mud. And I need the derivative properties for that. Which means it's pros and cons, right? If I want to be more efficient and get the answer quickly, I just have to be very careful and aware which property says what. In combination, they're going to help me get the answer every time. I just want to know how are they being used so that I don't make a mistake because eventually this list is going to get some more entries and the further down we go in this list, the more complicated they look. And I don't at that stage want to worry about these first four. All right, let's just do another one. Why not? I think two is a little straightforward. Let's go with four. I just need to drag it over so I can copy better. Okay, number, what was this problem? 5.2 still. We'll move on to 5.3 tomorrow. One step at a time. Maybe you need a lot of time to just get this solid. I want to give you that time. I'm just that nice. That, and I know that I cannot emphasize the importance at this stage. Setting yourself up for success in the future. It happens now. I say it every semester. It's laughable, really. I say it to the point where I annoy myself. Stop saying it. But I still do. Because every time people don't take me seriously when I say this is the moment, these days set you up for an easy ride into the rest of the course. Or not. That's up to you. They don't believe me. No one ever believes me. And then a month from now, things fall apart. And I know when it happened. It happened today because people didn't practice. So there's a very easy recipe for success. Because everything builds on top of everything else, when something new happens, really get that solid before moving on. We have the time. Do it. Okay, first property that we're going to use is an answer that you provide anytime now. First property. Some difference. See, it's already 2 questions in, it got better. Look at that. Didn't even take long. Now, those are technically two separate properties, but we merged them as one because they pretty much look the same. I'll merge them into one. There's no harm in that. So I have the first term. Notice how if I did this, that's technically not the sum difference property. That's a -1 that I put in front. That's the constant times a function property. And that's not what I'm doing right now. I'm trying to see one property at a time. So there's a fine line between the two in some cases. And squeeze in that last one like so. There we go. All right. Now, maybe I just want to see this as 5 times 1 over x squared, so that I can see that the constant times a function property is also necessary for this one as well as the first two. So -4, the number a in this could be anything. Could be positive, negative, doesn't matter. As long as it's a number. So the -4 goes in front. I'm isolating the power of x. I know power rule is coming. I'm almost there. Isolating the x squared, isolating the essence of the function. We see, and the transformations sort of start that idea, that if I look at the 3x squared, that is a quadratic function. That is the x squared function, essentially. It's just stretched a little bit. It doesn't change the fundamental type of function I'm working with, which is why I call it the essence of the function. The x portions tell me what the function really is. The rest of it is just transformation fluff around it, not really altering the shape of that graph fundamentally. No one really talks about the essence of the function. I don't know why. It helps a lot. And I've obviously used constant times of function throughout. It was the same property for all of them. All right. Power rule time for the first one for sure. Whoops. Rule. -4 stays in front. The 5 goes in front of the x, and the new power is 4. 3 is already in front. The 2 goes down. New power of x is 1. You can write the 1 there if you want to. But because it's a 1, you don't have to. I'm not going to, because it looks weird. Is that last term ready for the power rule? Not really, no. Yeah. It doesn't look like the power rule wants it to look. But there's no other property, so I might want to, let's maybe some arrows there. I just want to see it as x to the power, and it's going to be a -2. Make it easy for yourself. Don't try and, I see people, you try and make slight variations of the power rule so that they can handle 1 over x to the power of something. Just write it as x to the power of something. Don't overthink this. Then the -2 goes in front. The new power of x is, so many questions today. It's so annoying. I know, I'm sorry. -3. You'd be surprised. In the heat of the moment, in a test, you can so easily write -1. It happens so easily. Always think, always think. And now you could totally stop there if you want to, but the simplification isn't hard, so I might as well do it. Two negatives make a positive. You can leave it as x to the -3, or you can say 10 over x cubed. You can do whatever you want. They're all the same. Doesn't matter to me. Whatever makes you happy. Now, after a while, I'm not going to lie. I can't tell when that's going to happen for you, but after a while, you do start to look at this, for example, for -4x to the 5. And you start to realize, well, the power rule is eventually going to happen, right? The -4 is really just waiting for the power rule. It's getting dragged along by the constant times a function property. All right, so it's not really anything I need to worry about because the constant times a function property allows me to not worry about it. It says, don't worry about it, just drag it with you in front. But that property allows me to do that. Then finally, when I've isolated the power of x, and the power rule is applied, I know the power of x is going to go in front and essentially in simplification merge with the constant, with the coefficient. And because this is going to happen every single time, it happened with the 3x squared. The 3 is going to wait, 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 because of the constant times a function property, until the power rule is eventually ready. The 2 will come down, merge with it for 6. So it takes as long as it takes for you. Don't rush it. But eventually you want to practice enough so that you can see, well, it's going to be 5 times negative 4. The 5 goes in front and can immediately be merged with the negative 4 because it's going to happen. I don't need to drag this out over 4 lines. It's always going to happen. The 2 will eventually go in front and merge with the 3. And once I'm ready, and you'll know when you're ready, you can do that right away. Right away. Now, so I could, after a while, I just have to read the question. If the question wants me to pull this apart and say every property I'm using, then yeah, do that. But if I just want to find the derivative, just find the derivative. You don't get any extra marks for saying every uh, property. If the question doesn't say, you have to do that. And you just want to find it. Let me just copy it again here. What was it? Negative 4x to the 5 plus 3x squared minus 5 over x squared. And I just want to find it. Let's suppose that's my goal. Then I can say, well, I've seen this now thousands of times. And I can merge it and say negative 20x to the 4. But be sure that you are ready for it. Some people could be ready now. Some people will take 10 more practice questions in the detailed way before they're ready. There's nothing wrong with that. What is wrong is when you rush it and you're not actually ready, meaning you don't really understand. Things are going to fall apart. Do it when you're ready. And if you're never ready, that's also okay. That's also okay. Then the next one, I know is going to be a plus by the sum property. I know eventually the 3 is going to hang out, waiting for the power rule to bring down the 2, so it's going to be 3 times 2, and the x is 1 less. I know this is going to happen because I've done enough of the detailed versions to be sure, to be comfortable. But I can't predict when that's going to happen. And maybe now I know, I'm not sure about this last one. I know by the difference property, I still have to find the derivative of that last term. But to me, at this stage, maybe, this looks a little, I'm not sure, not as comfortable as I was with the first two. So I'm still showing myself and reminding myself that I have to still look at the derivative of this guy. I wasn't sure to do it in my head. I wasn't comfortable. Then don't do it. It's fine. This just means I still have to do it. So I'm finished with the first two that I did feel comfortable with, perhaps. And now this one I'm not quite sure. So now let's take our time, perhaps, and make sure. And now I see, okay, well, it's 5 times 1 over x squared, which is x to the negative 2. Okay, now it looks a little better. Okay, now I'm sure. I wasn't sure in the beginning. I just wanted to pause and be sure. Okay, now I can look at it. When I'm done with the other two, they're not distracting me anymore. I can now focus on this last one that I have to do. And now see, okay, well, it's minus, because this minus. I know the negative 2 is going to come down with the same argument as before and merge with the 5. So I'm going to get a negative 10, and x is going to be 1 less, like that. And then you can simplify this if you want to. Please, for the love of all things, use brackets to make it clear. It's when people write things like that and they write a little dot there, but the dot is so soft, so faint, they can't even see the dot. Now I don't know what is happening here. There has to be something here. Some symbol needs to be put between those two. People love their dots, and I don't know why. Put brackets. There's no confusion anymore. Now you can stop there if you want to. It's like, I'm lazy. I don't want to simplify. I spent my whole high school simplifying. I'm done. That's fine. I have no need to simplify. But if you want to, you are welcome to. I don't really care moving the x to the bottom. It serves no purpose for me personally. So I don't know where you are in your progression. I don't know. I'm just giving you options. So I do have to pay close attention to what the question is asking. If the question says use the limit definition, I have no choice. But it's going to keep the function simple. It's not going to take this function and say use the limit definition. It'll take me like an hour. It's not appropriate. It's okay. If the question says find the derivative, but state the property that you're using on each line, then you have to do it that way. If it just says find the derivative, then do it however you want. Show as much or as little detail. It's up to you. Now, in so for example, we'll just scan ahead at problem 5.3. I'm not doing 5.3 yet. That's for tomorrow. But see here how it says stating each property used. That means stretch it out. Say each property. Show the detail. Don't use the limit definition, but don't do it in the shortest way possible either. So be aware of what the question is asking. Okay. Let's actually just do this number one in a way that we can handle right now. Why not? Oopsie, what did I just do? Okay. I don't know if I should. No, maybe not. Let's not do that. I have more than enough time tomorrow. Never mind. Let's just practice some more. I'm just excited. I want to go to the next portion, but we might not be ready. Let's see. Let's do number 5. Yeah, let's do it. That means I'm in the wrong page style, isn't it? Yeah. New letter. Oopsie. Too much zooming. Okay. Problem 5.2, number 5. I want to find the derivative. Oh, that's a square bracket. Derivative of 5 times all of 3x squared plus 5x plus 1, like so. Showing all the steps, stating each property. That's our level right now. Okay. However, I have to look at the function. What am I working with in the square brackets? I have some options. I have some options. Option number 1 is what most people I think would do is multiply the 5 in. Let's simplify this first before we worry about the derivative. So that'll be negative 15x squared plus 25x plus 5. Right? And now we'll do a couple of lines together sometimes. As long as you state all the properties that you used for that line, you're okay. So I'll use the sum difference property first, which allows me to isolate the terms like so. Sum, it's all the sum property. Sum property. Now let's show. I could do multiple ones here. I could say negative 30x. What property or properties did I use? I used multiple properties in doing that. First property that I used was what? This is awkward. Constant times a function. Constant times a function. But we also use the power rule right afterwards because perhaps we were comfortable to do that and we did it. That's okay. Now we're going to do it again. Well, this is the power of 1 there, right? So it's 25 times 1, so it's just 25 for the second one. Same properties that we used. We used constant times a function to keep the 25 in front. The power rule is technically the one that says derivative of x is 1. And then we can address the derivative of 5 as well, being 0. So I have to add another property here that I used for that line. That's okay. Constant property as well. And I'm not going to bother simplifying that any further. Give 0 his moment in the sun. So I could slowly cross over. Yes, still write all the properties. List them on the side. But start merging lines together as it naturally gets comfortable to do so. You decide. Don't rush it because you don't want to do more practice. If you'll know if you're ready to do it and merge stuff and do it quicker, then it'll happen naturally. Okay. The other option I had here, however, if I look at the original, whoa, that should be there. I'm just going to copy it down again. 5 times negative 3x squared plus 5x plus 1. The other option is that I could recognize that it's 5 times some other function, which means the 5 can be kept in front, and then I need to find the derivative of the function that's left. That is the constant times a function property, which means I still have to figure out the derivative of the inside. Now maybe I will separate it into a couple of lines. Don't try and do all at once, but you don't have to show all the detail one at a time. Some comfortable middle ground, like so. And I've used my sum property. Is that correct so far? It was really a yes-no question. It wasn't yes, no, or silence. There are only two options, yes or no. Is that correct? I don't know what to do with silence. Hmm, not sure. Ah, that's what I'm getting, silence. I'll keep going. Then, okay, he says yes. All right. Then we can now merge some stuff here. We have the 5, fine. We know that the negative 3 will go with the 2 to make negative 6. I don't love that dot if I have a negative integer. Not a fan. It can easily be misread. And I have an x, right? 1 power less. So I've used the constant times a function property again. Oops. I've used the power rule. That's pretty much it. Then the 5x, derivative 5 will stay in front. Derivative of x is 1, so it merges with the 5. Same properties. And then the derivative of 1 is a 0. Okay, so I have the constant property here that I did as well. Okay, that's fine. I can just list more and more as I do more and more. Everyone happy with that? As our last minute rolls in and we're almost done. I might want to leave it like that. I might want to simplify. like so. Well, I don't get the same answer as I did up there. What happened? You said everything was fine. I kept going. My answer's not the same. It's the same question. The answer should be the same. So something happened. What happened? Yeah, I need to keep the brackets, but it's so easy to miss. Technically, there are brackets around here, right? The 5 needs to be multiplied with the derivative of whatever is left, which means I need brackets here, which means I need brackets there, which means 5 applies to the negative 6x and to the 5, and now it's the same. Very easy. I did it on purpose, of course, but it's very easy. If you're in a little bit of a hurry and you just glance over things, it's very easy to miss a bracket and then it's unfortunately wrong and you lost the mark when you really shouldn't because you did all the derivative properties correctly. Okay. So practice. We have problems in the other textbook. If you want to look at more problems, there's really no end to these kinds of questions. But hopefully you feel a little bit more comfortable. We'll practice these things again tomorrow. They'll keep coming up for the next couple of days, so don't worry about. We're not going to jump. Even when we make, when we not make, when we introduce more properties to our list, these properties are still going to be there. We're still going to rely on the ones we have so far. They're sort of at the base level. You can't escape them. They're always there, being used. And we get used to them so quickly that we forget that they're there. We just use them without thinking. And that's when things can go wrong. If I stop being aware of what I'm doing, then mistakes can creep in without me even realizing it. So we want to build up our list of properties at a comfortable pace. All right. Let me know if you have any questions on what we've done so far. It's ultimately up to you to establish your base in a nice solid way so that when we build on it, uh, everything will continue to go well. Otherwise, we will continue this tomorrow. Until then.